Thanks to the organizers for putting this together. I'm not going to repeat myself with my name. I'm here on behalf of our Chief Scientific Officer, Jennifer Brownlee, who couldn't attend. So I'm here to talk about Vertical Future, and I'm very conscious about the time, so I will start saying that we have a booth out there. So any question you have, please reach out. We will be there during the rest of the day. So yeah, let me show you who we are, what we do, what we offer. Long story short, 30 seconds of context. Vertical Future started in 2016. Our founder and CEO used to be a grower, so he used to grow in a vertical farm with the available technology at the time. And after 3-4 years of producing, he realized there was a space to improve the technology. So he decided to change the company from a grower into a technology and data company. And that's how, at the moment, this is what we offer. You can see we sell basically a turnkey solution for vertical farm. The irrigation canals, the lights, all you need to have your farm up and running. And all of that goes with the software that I will talk about there very briefly. How do we do this? How we approach this problem? So for us, success means healthier people, healthier planet. That's why we're here. That's why we're also involved in COP28. We base our innovation in scientific trials. Also, we have a strong team of engineers. So the engineers build, design, the plant scientists, such as myself, we test the system, and the commercial team brings the number together. We believe vertical farming is a new, useful tool for the sector. There's no silver bullet here. This is another tool to be used, and we need to learn how to use it. We believe in price parity with open field. That has to be done through automation and large-scale vertical farms. With the years, we have been building our brand. We are part of, you can see names of our network. So we are currently a global leader in vertical farming. We manufacture pretty much 90% of all the components. So we design, we manufacture all that is in there, all the way from seeding to harvesting, going through automation, irrigation, so on and so forth. And we believe it's important because it gives us the flexibility to improve every single component. And if we can improve every component, we can increase the efficiency. More efficiency means more profit. This talk is sort of divided in 3 main areas. The first one is operational efficiency. The second one is environmental impact. And the third one, it will be new varieties. So this is the first section. Don't worry, it's not too long. It's a couple of slides per section. And I would like to talk about this with an example. So this is an example of chart. Each color is a different chart variety. And the message here is like, so far in the first green revolution, the plant varieties was very important, was the key. And at the moment, as we have heard before, in addition of the varieties, the technologies is very, very important. So different varieties of chard grow differently depending on how you grow them. And the key message here is like all varieties which are not commercially relevant in open fields perform better in indoor farm. So this was a clear invitation for us to go back and look for all varieties that are there and not very commercially relevant in the open field, but they have a huge potential for indoor farming. So the next challenge is we had, for instance, is how do we optimize our light as an operational efficiency? And as you can see here, this fresh weight in different light recipes. So our optimized light recipe has a penalty in yield, so it's slightly lower than the traditional light recipes. However, we can reduce the energy used by 30%, so that penalty is compensated by the efficiency of light largely. So we are more efficient, and if you can reduce your light, you can also reduce your environmental impact. So you have a win-win situation. And let me focus the environmental impact in terms of carbon footprint. So this is how, in yellow, we can see how vertical future produce compares to traditional open field UK supply, which is already better compared to a 5-month local production in the UK, 5-month importing from Europe, and 2-month importing from Africa, which is what normally happens at the moment. But here, the relevant is the last bar. If we go with clean energy, for instance, wind, we can reduce that carbon footprint hugely because we can produce very close to where the distribution center, we have heard in the previous conversations about chain supply. So vertical farming can fit very nicely in that chain supply sort of scenario. We also did our internal carbon footprint life cycle assessment, and as is well established, most of the carbon footprint in the operation is not in the hardware, it's actually in the operation. So if you can operate your farm efficiently, you are saving money, but also you are reducing your carbon footprint. In terms of percentages, it's about 80% goes to operation, 20% goes to hardware. And within that 80% of operation, 50% is pretty much light. So if we go to light, we are already in good business. So this is an example of the carbon footprint in a traditional light regime, which is the bar on the right, and an optimized light regime, the one on the left. So if you reduce, you have your lighting optimized, we managed to reach 20 grams of CO2 reduction per kilograms of produce. So we believe that's the way forward. We believe this makes us different, and we believe that's the contribution of vertical farming. And this is the final part of the presentation. Come back to the first point about new varieties. And there's a huge potential out there. We're focusing on amaranth, just as an example, because it's a very attractive source of protein. It's been well known in some areas, South America, Africa, and it's less known in Europe and other areas. But we're doing some research here, and it has a very special characteristic. It has a complete protein, which means it has 9 essential amino acids, which is very rare in plants. So normally plants don't have 9 essential amino acids. Amaranth does have, and we're doing this research with the University of York. So we're linking this with biofortification, for instance, we were discussing just before. So it's an excellent source of protein both for adults and children. If we look at amaranth in terms of carbon footprint, it's also very low. Currently, amaranth, if you feed your farm with electricity from the grid, you're comparing it with sort of grain. That's the carbon footprint that it has. But if you go again to green energy, you can reduce that to peas, which is very, very low in carbon footprint. So you have a good source of protein with a very low carbon footprint. And this is the final slide, is the glue that puts everything together. So all our trials, all our innovation goes into the software that we call Diana. And this software gathers the information and makes it available for whoever is operating the farm. We also push all our updates through the software. So it's like buying a laptop or a computer, and it will be up to date with the time. So all the innovation and the improvement will be there. Light recipes, fertigation recipes, how you move your robots in the automation, all of that is bring together by Diana. And that's the final. I believe I am on time. So thank you for for being here. And please reach out. Also, we have a round table immediately after. So please, you're more than welcome to join. Thank you very much.